All right, chapter 10 in geometry deals with intro to finding area of different figures. So some of this will probably be review. You're probably like, oh, I can do these. These are easy. And you probably have done these, but this is, again, building up to us finding the area of different polygons and other shapes like that. So we're looking at parallelograms and triangles specifically in this section. So the area of a parallelogram is found by taking the base and multiply it by the height. The height of a parallelogram is the altitude of it. And so the altitude of a parallelogram drops at 90 degrees and intersects the base at a 90-degree angle. Okay, it's like that. Parallelograms have two different altitudes, usually, going to the opposite bases. And what you'll do is you'll multiply the base in which that altitude or that height intersects with. That's going to be the height that you multiply it by. Okay? And it doesn't matter how far lenient it is either way. You're looking for the altitude and you're multiplying it by the base of it. Okay? So base times height is to find the area of any parallelogram. Because what you can think of happening is here is you can make this into a a rectangle by taking this triangle and moving it over here. And then what we have is that we have this nice rectangle where it's easy to find it. And that's what all parallelograms are happening, is that you can take that small triangle and shift it over and you make a rectangle. Okay, so find the area of this one. So again, it's a rectangle of 25 meters by 14 meters. So what you would do is that you would just multiply 25 times 14, which gets you about 350 meters squared. Since we're talking about area, we're going to be using meters squared, or whatever the unit is squared, which is how many 1 by 1 squares can fit into that object. So make sure you put units squared. It's important that you put it squared, because that's indicating that we're talking about area and not just length. Okay, so this is pretty easy, just base times height. So find the area of this one. So as you see, we've got a parallelogram where we've got one side is 8 millimeters, and then we have this line coming down, which is 6 millimeters, and then the length from the end of this base up to where the altitude touches is 7. And now the question is, well, what is the area? Well, the only numbers you're going to use is you're going to use the altitude, the 6, okay, and you're going to multiply that by whatever the base is. And the base is this number. You don't worry about how far you have to extend over. You want the base of the original object. So it'd be 6 times 8. So 6 times 8, 48, and then it would be millimeters squared. And that's just the area. So again, this should be pretty straightforward, pretty simple. Alright, so now this one, what we want to do is we want to find a side length. So we want to find this x way down here. That's kind of hidden at the bottom. So we want to find that x of this figure. Now by looking at it, you go, well, you know, we don't really have enough information to solve it. Well, actually we do. And we're going to use area to help us find this. So what is the area of this figure? Well, if we want to find the area of this figure, we've got this base, 15, and we've got a height of 8. So we'll go 15 times 8. Okay. We'll go 15 times 8 and find what our area is, which ends up being about 120. So now we know that the area of the blue object is about 120 meters squared. Well, if our height is 12, our altitude is 12, then we multiply it by its base and it must equal 120. So we go 120 is equal to 12 times x. Solve for x and we get 10. So that means that our length of the other side must be 10 meters. So see, using area, we're able to find missing parts of this figure by using the other information to find what the area is. And the area is always the same no matter what angle you're looking at this object. If you're looking at it from this angle, it's going to be 120. If you're looking at it from this angle, it's 120. You're looking at it this angle, it's 120. If you're looking at it straight on, then it's 120. If you're looking at it from behind, then it's 120. No matter where you're looking at it, it's still going to be 120 meters squared as the area. So wherever you can find that altitude and that base, you're able to do it. Now, a triangle. Okay, so the area of a parallelogram was just base times height. A triangle is 1/2 base times height. Okay, so 1/2 times the base times the altitude. And the reason for that is because if you put two triangles together, you create a parallelogram. So if you put two identical triangles together, you always make a parallelogram. And so to find the area of only one of them, you just take and divide it by half, the area of that parallelogram. Okay, so 1/2 base times height. So here would be your base, and then your height again is the altitude of it. Okay, so it's dropped straight 90 degrees down. Okay, and so that's a triangle. Okay, so find the area of this. So we've got a triangle with a base of 9 and an altitude of 4. And see, we don't even need the other two parts, other two sides of this, because of the information we have. And so we'll plug it into our formula of 1/2 times 4 times 9. 1/2 times 4 times 9, which looks like it'll get us about, what, 18? 18 inches squared would be our answer. And that is our area of this triangle. Okay, so 1/2 times 4 times 9 gets us 18 inches squared. Pretty simple. All right, so now let's say we have this figure. And so we have a kind of like a house type shape, or if you want to think of it, it's like a baseball home plate for a baseball field. And we want to find the area of it. And so I give you different parts, and there's not like a quick easy formula to be able to figure this out, because it's not a typical shape, and it's a pentagon. And so what you'll do is that you can break it up into parts. So you have this green line that's drawn, and now you see we have a triangle, and we have you have a triangle, and then you have a rectangle that are being attached to each other. So if you can find the area of this triangle and then find the area of this rectangle, you just add them together. And so the area of the triangle would be 1/2 times the base, which I'll say is 5, multiplied by the height, which is 12, which ends up getting us about 30 miles squared. And then the rectangle would be 4 times 13, which gets us about 52. And so then we would add those two together to get our answer of 82 miles square, or square miles. Okay, so as you see, if you're given a shape that's, okay, it's not a rectangle, or it's not a parallelogram, or it's not a triangle, try to break it up into parallelograms and triangles, and then just add up the areas that you have. Okay, that would be the easiest. Okay, so now the question is, what if your triangle doesn't have a height? There is a way to do this if you can figure out the angles. Okay, there's some trig stuff that you can do. We haven't really gone over that too much because we've only dealt with right angle trig. But there is a way of finding the area if you have no height. So if the only thing you're given is all three sides of a triangle, and you know it's not a right triangle, to find it, you use something called Heron's formula. And Heron's formula is kind of a two-step formula. You have to do the second one and then plug in that S into the 4 spots it is in the previous one. Okay, and then you use that to find the area. So A, B, and C are your sides. So 14 is A, 13 is B, 18 is C. And so what you'll do is you'll add up all the sides, divide it in half, and you'll get a number. And it's always going to be bigger than any of the sides individually. Once you have that, you take that and you plug it in to the rest of the problem. So as you see here, we did 14 plus 13 plus 18 divided by 2 gets us 22.5. And now for our area, we're going to take the square root of 22.5 times 22.5 minus 14 times 22.5 minus 13 times 22.5 minus 18. So you add all that together, or you subtract those and you multiply it all together, and then you get an answer of about 8,175.9375. And you take the square root of it, and that gives us the area of this figure, which is about 90.42 feet squared. So remember, your unit, feet squared, whenever doing an area, it's whatever squared. Okay, so that's Heron's formula. It's a little bit confusing, but it helps with certain triangles where you don't have the height. Okay. All right, your IRAT for this one. So you're given this hexagon, and it's not necessarily a regular hexagon, but I give you enough information to find this. This top half right here is the same as that bottom half. So they're the same on both sides, and it is a rectangle in the middle and everything. So find the area of this hexagon. So break it up into the triangle and the parallelogram, and then add them all together.